this lesson, you're going to write an equation in slope-intercept form given a point and one slope. And you're going to write an equation of a line in slope-intercept form when we're just given 2 points. A constraint is a condition that a solution must satisfy. And a linear extrapolation is the use of a linear equation to predict values that are outside the range of data. So on the last video where we did that with predicting how many girls were in sports in the year 2017, that's using linear extrapolation. You're predicting something outside of the range of data. We're going to do that again here today. So if a line passes through 2, 1, and it has a slope of 3, and we want to write it in slope-intercept form, we need to know 2 things. We need to know this, and we need to know this. Well, we know the slope. What we don't know is the b, and we can't just guess. So what we're going to use is substitution. Here's how it works. This is our equation. Y is a coordinate, so we're going to put a 1, because that's the y coordinate. M is the slope. X is a coordinate, so we're going to use the x coordinate. And now we don't know b. See what we can do now? We can solve for b. So 1 is equal to 6 plus b. Subtract 6, negative 5 is equal to b. So now we know our b. So we can now just put it into the equation. Y equals mx plus b. Y stays y, x stays x. The m is your slope, and then my y-intercept is negative 5, so it's a minus 5. So this is my slope-intercept form given that point in that slope. Try the example in your notes now. What if I have 2 points? Well, then I'm going to have to use slope formula. And I put that in your notes for you. It's m equals y2 minus y1 over x2 minus x1. So we're going to have to use these 2 points to find the slope. Remember, this is x1, y1. This is x2, y2. So here we go. M is equal to y2 minus y1 over x2 minus x1. Simplify. So m is equal to 3 over negative 1. So m is equal to negative 3. If you divide that out, you get negative 3. So I know my slope. Now I need to find my b. Well, what's kind of nice about this one is you can pick either point to plug in, and they'll both simplify to the same b. That's kind of nice. So I'm just going to pick the first one, and you could really pick either one. So remember what we did last time? Y, I'm going to choose the 1, is equal to m, which is negative 3, times x, which is 3, plus b. So I simplify now. 1 is equal to negative 9 plus b. I'm going to add 9, and you get 10 is equal to b. So our b is 10. Now that I know my slope and I know my y-intercept, I can write the equation. Y is equal to negative 3x plus 10. Slope, y-intercept. So in this example, when you have 2 points, you have to find the slope first and then choose one to plug in to your equation. Try the example in your notes. Now, we're going to do another one with 2 points just to keep practicing here. Practice this with me. So y2 minus y1. I picked one that was a little bit harder this time. Can you tell? We're working double negatives here. Over x2 minus x1. Remember how we simplify this? 2 negatives together make a plus. So I'm just going to go ahead and just cross those out and plus them here. So this is negative 6 plus 2, which is negative 4. This is negative 5 plus 4, which is negative 1. Do you remember what happens when we have a negative over negative? We had that on a quiz, and some of us were confused what would happen here. This is m equals positive 4 because 2 negatives make a positive. So since I have my slope, I need to now find my b. And I'm going to choose either one. So let's choose this first one. Y equals slope, which is m, times x plus b. Simplify. So negative 2 is equal to negative 16 plus b. We're going to add 16, and we get 14 is equal to b. Do I have enough now to write the equation? You bet I do. Y is equal to 4x plus 14. Okay? If you need to try another example, make sure you do. How about a real world example? These are a table of flights. In the year 2004, there were 9.97 million flights. 2005, 10.04 million flights. So in this table, we have all of this information, and we want to write an equation using to predict the number of flights if it continues to decrease at the same rate. So we need to find a slope, and we need to find a y-intercept. First of all, what's going to be x and what's going to be y here? Well, it's important for us to remember that slope is also rate of change. So a change in quantity over a change in time. So this is going to be our x values, and this is going to be our y values. So we're going to do how much is this changing in quantity over how much is this changing in time. So we just pick a couple values. You seriously can pick any that you want. I'm picking these two. And what I'm going to do is do the change in y. So 9.84 minus 10.04 over the change in x, 2007 minus 2005. When you subtract this, you know it's going to be negative. And if my math is correct right here, I'm thinking it's negative 0.2. I can check that with my calculator if I need to. And then this is going to be a positive 2. Okay, so let me just double check that real quick. So I have 9.84 minus 10.04. And that's negative 0.2. And then I divide that by 2. And so my slope is going to be negative 0.1. Now I just pick one of these points to plug in to find my b. So I'm just going to pick the 2007 one. That's okay. So I do y equals m, we just found that here, remember, times x plus b. So I have 9.84 is equal to, I do this negative 0.1 times 2007, and I get negative 200.7 plus b. Now I have to add this. And so I add 200.7 plus 9.84. And I get 210.54 is equal to b. Now we can write our equation. Y equals negative 0.1x plus 210.54. Now this equation we want to remember because we're going to use it to do some linear extrapolation. So I'm going to go ahead and copy this right here so that we can put it on the next page. So based on this equation here that we just found, we want to know the number of domestic flights in the year 2020. So remember what this stands for here is this is going to stand for our years, and this is going to stand for our number of flights. And so when we look back here, this was from 2004 to 2008. So when we plug in our 2020, let me just check right here where we're at. When we plug in our 2020, it will be, let's do since the year 2000. So let's make this 20. So negative 0.1 times 20 plus 210.54. And when you guys do your real world example, you'll know where to start from because it'll be on your graph. It'll be your origin point. So we're going to multiply negative 0.1 times 20. And I know what it is, but I'm just double checking here to make sure my math is correct. So this is 20.1 negative, because a negative times a positive is negative, plus 210.54. So then I'm just going to add that on my calculator here. Oop, my math is wrong here. All right, let's try this again. This is negative 2 plus 210.54. And hopefully you are doing this along with me and you can double check that as well. So it's 208.54. Remember, this is going to be millions. And this is going to be the number of million flights in the year 2020. There's a real world example in your notes. Go ahead and try it. And then if you want some help, you can either text me or we can wait and work those problems together in class tomorrow.